What's up everyone, Patrick here, welcome back. Moving on to the next example, and this example here, you don't have to write it out, it's in the lecture notes at the beginning of the chapter. You can print out the PDF and you can go straight into writing the solution. So what are we working with here? We're told that a law firm has the following monthly expenses, so over here, where the cost driver for any variable or mixed expense is the amount of billable hours charged to clients for that month. So notice that we have data here for January, February, March. We have the billable hours in the first row, and then we have the expenses. So this law firm has 5 different expenses, and then we have the total of these expenses. And then we have to answer these 4 questions here. So number 1, we have to identify each expense as fixed, variable, or mixed. Number 2, for each mixed expense, use the high-low method to find a cost formula. Use the high-low method to find a total expense formula. And then number 4, the billable hours in April are expected to be 800. What is the minimum amount the firm needs to charge per billable hour in order to be profitable? All right, so let's get started. So number 1, we have to identify each of these costs here as mixed, variable, or fixed. So the easiest one to always identify first is the fixed cost, because a fixed cost, if you remember, what's the format of it? It's basically y equals some kind of constant. It's just going to be constant the whole time. And so let's just split these up because billable hours are not expenses. So out of these 5 expenses here, which one is staying constant every month? Well, notice the rent is staying constant every month, $50,000. So we know the rent is a fixed cost. What else is staying constant? The salaries are $215 each month, $215,000. So we know the salaries are fixed as well. And then notice the advertising, insurance, and supplies, they are changing every month because that cost driver is changing. So the cost driver in this case is the billable hours. Notice it's 400, 500, and then 700, right? So these 3 remaining expenses, advertising, insurance, supplies, those are either going to be a variable cost or a mixed cost. The question is, how do we figure out which one is which? Well, the easiest one to figure out after you get the fixed costs is to figure out which ones are variable costs. Why? Because variable costs are always going to be in the format y equals mx. There's not going to be a plus b, that plus fixed portion. That's going to be a mixed cost. And so really, notice that for each month, we're given the total cost of each component, and we're given the cost driver. And so if an expense is a variable expense, then basically when you take that total cost of that component and divide it by that cost driver, that amount, when you do that for each month, should be constant the whole time. So let me show you what I mean by this. So if we take advertising, let's take that total cost of $15,000 and divide it by the cost driver, 400. And when you do this in your calculator, you'd end up getting 37.5, like that. Now what you want to do is you want to take the next piece of data, so the next month, 17,500, divided by 500, and then when you do that there, that here is going to give you 35. And so right there, because these 2 numbers here are different, you know that advertising can't be a variable cost. It has to be a mixed cost. Because if it was variable, then whenever you do this, that's just going to give you the slope, and the slope should stay constant. But because that slope didn't stay constant, there's another portion to this cost, there's actually going to be a fixed portion, a plus b, which is going to make it a mixed cost because these values are not constant. So that's how you could tell quickly whether something is variable or mixed. So if we do that to insurance, same thing. We would take the insurance 6,000 divided by 400, and when we, or sorry, not 6,000, 60,000. We'll take 60,000 divided by 400, and that's going to give us 150. Now let's take 75,000 divided by 500. That's going to give us 150. Now let's take 105,000 divided by 700. That's going to give us 150. And so because these numbers are constant, we know that that's going to represent the M. We know that insurance is going to be a variable cost, right? Because the 150 is basically going to be the M. So the formula for insurance, now that we're here anyway, is basically going to be Y equals 150x, right? Where M, the 150, is going to be the variable cost of the insurance per billable hour. That's the cost driver. And yeah, that's going to be the formula. And then if you take this formula and you use it with these billable hours, you would get these numbers. All right, so the insurance is a variable cost. Now the supplies, let's do that same test. So the supplies, if we take 6,000 divided by 400, we're going to get 15. Then if we take 7,000 divided by 500, we're going to get 14. So because these are different, we don't even have to go any further. If you took 9,000 divided it by 700, it would be even different than these two. But the fact that these two are already different, you don't have to waste your time in going further. We know that supplies, it's not a variable cost, it's not a fixed cost, it's changing. So what's remaining? It's a mixed cost. All right, so that's how you could figure out if something is fixed, if it's constant, if it's variable. These values are going to stay consistent. It's just going to be that M. And then anything else that doesn't fit one of those two criteria is going to be a mixed cost. So the rent is fixed, the advertising is mixed, the insurance is variable, the supplies is mixed, and then the salaries is fixed. Right, so we're done number one. Now for number two, what we got to do is we got to take each mixed expense, which in this case it's advertising and supplies, and we have to come up with a cost formula for them. So remember, a mixed expense is going to be in the format Y equals MX plus B. There's going to be that fixed portion there. And so to find a cost formula, let's start with advertising. We're going to be using the high-low method. And what we do is we take the lowest amount of the cost driver in the data, which is January, 400 billable hours, and we take the highest amount of the cost driver, which is 700 in March. And so what we're going to do is we're going to be using those 2 months to come up with a formula for advertising. So the two coordinates we're going to use is 400, and then the advertising is going to be 15,000 for billable hours of 400. And then for 700, the billable hours, or sorry, for billable hours of 700, the advertising expense is going to be 22,500, like that. Right, so we have two coordinates here, and we basically have to find the equation of a line that goes through these two coordinates. So first thing we would do is we would find the slope. So we would take this minus that, so 22,500 minus 15,000 divided by 700 minus 400, like that. So this would be what? 7,500 divided by 300, like that, which would give us 25. So M is $25 per billable hour. right? So for this, we know advertising is going to be y equals 25x, and then we're going to have plus b, like that. But now what we got to do is we got to solve for that b value. And the way we could do that, we can pick one of these two coordinates and plug it in for x and y. I'm going to pick this coordinate here, so I'll have 15,000 equals 25 times 400 plus b, like that. So we'll have 15,000 equals 25 times 400. That would give us what? 10,000? And so when we isolate for that b, bring the 10,000 over, we would end up getting 5,000. And so the formula for advertising, let's just call it advertising equals 25x plus 5,000. Where x, in this case, is the amount of the cost driver, and more specifically, in this particular question, is the amount of billable hours. And if you want to make sure that you got the right formula, what you could do is you could plug in 400 for x, and you should get 15,000. Plug in 700 for x in that formula, and you should get 22,500. Now, the remaining mixed expense is the supplies. So let's work with supplies here. Exact same process. We're going to be using the exact same months because it depends on, the high-low method depends on the highest and lowest amounts of the cost driver, not the cost, right? So we're still using January, still using March, but now the coordinates we're going to be using is 400 and 6,000 and 700 and 9,000. That's what the supplies was at that amount of billable hours. Right, and supplies, again, it's a mixed expense, so it's going to be in that y equals mx plus b form. So let's find that slope first, the m. So it's 9,000 minus 6,000 divided by 700 minus 400. So it's basically 3,000 divided by 300, which would give us 10. So the m is 10. So the supplies, the variable portion of supplies is going to be $10 per billable hour. So we're going to have y equals 10x over here. And now we just have to find that remaining b value. And so we could use either of these coordinates. I'm going to use the first one. So we'll have 6,000 equals 10 times 400 plus b. This would be 4,000. Bring it over. Basically, b is going to be 2,000. So the formula for supplies is y equals 10x plus 2,000. And again, you can do a check. I'm not going to put y here. I'm going to keep it consistent as up there. You could check the formula. So you can plug in 400 into the x, make sure that you get 6,000. And then you could plug in the 700 for the x, make sure you get the 9,000. Okay, so from here, we found the cost formula for the two mixed expenses, the advertising and the supplies. But we first had to figure out which of these expenses are the mixed expenses. And then once we knew, we just apply the high-low method. Now what we got to do is we got to find a formula for the total. So we're going to do the exact same process. Now, I mentioned this in a previous question. If you have the formula for each expense of the overhead, there's another way to get this formula. It's a nice way to check your high-low method, is you can add up the formula. So notice that we have the rent. We know that's a constant. So that's 50,000. We know the advertising is mixed, and the advertising is 25x plus 5,000. Then we have the insurance, which is 150x. And then the supplies is 10x plus 2,000. And then the salaries is constant at 215,000, like that. So we took all of the formulas and added them up, and that's going to give us the total overhead formula, the total overhead cost formula. So we would just add the like terms. So we'll have 25x plus 150x plus 10x. That's going to give us 185x plus 50,000 plus 5,000 plus 2,000 plus 215,000. So that's going to give us what? 265,000 plus 7,000, 272,000. And so that there is the total formula. So it's a good way to do it this other way and check our high-low method. We're still going to do the high-low method, but just wanted to come up with the formula first. And hopefully we get the same value, then we know we're all good. Now, if we're going to do the high-low method, what we got to do, exact same thing that we did with advertising and supplies. Going to write this above here. So what we would do is pick two coordinates, still using the low and high cost drivers. So we'll have 400 and then 346,000. So we'll have 400, 346,000. Then we'll have 700 and 400 and 1,500. And then we just have to find the equation of the line that goes through these coordinates. So we'll have m equals 401, 500 minus 346,000 divided by 700 minus 400. And then when you do this, make sure, be careful with your brackets, do the brackets first, then divide those two numbers. You'd end up indeed getting 185. And so from there, we know that we're going to have 185x plus b. So we just have to solve for that b value. You could choose any of these coordinates. I'm going to choose the first one. So basically we'll have 346,000 equals 185 times 400 plus b. Then we'll have 74,000 plus b, 346,000. And then b would end up being, if we take the 74,000, move it over, we'll have 272,000. Like that, which is exactly what we got with the other way. Right, so this here would end up being 272,000, like that. So the total overhead cost formula is 185x plus 272,000, where x is the number of billable hours. Okay, so now the last question, what they said, was that this firm here, let's kind of split this up here, is now expecting that in April, the billable hours is going to be 800. And what they're asking is what amount has to be charged per billable hour in order for the company to be profitable. So this one's a little bit tricky. It's actually a nice introduction to the next unit when we're going to be doing cost, volume, profit analysis, but it's definitely, even though we're going to go into more detail in the next unit, this is a question that can come up in this unit as well. So basically, what is profit, just in general? Profit is basically equal to revenue minus expenses, or let's say total costs in this case. Now, revenue, we don't know yet. We're actually figuring that out. What amount of revenue is going to give us a profit? But we could figure out what the total costs are going to be, right? Because we have that total cost formula. So the total costs, what we can do is we can basically take 185 and multiply it by the 800 billable hours that are expected to come up in April, and then add that 272,000, like that. And when you do all of that in your calculator, you'd end up getting 420,000. All right, so $420,000, if there's billable hours of 800 hours, that's going to be the total cost. So taking this amount here, and let's put it in this formula. Now, in order for a firm to be profitable, we can figure out what's the minimum revenue it has to come up with. And the minimum revenue it would have to come up with is to break even when the profit is 0. So we'll have revenue minus, and the total cost is $420,000. So basically the revenue, if we isolate for it, we have to come up with a revenue of $420,000. If we come up with a revenue of $420,000, then that's going to cover our total cost of $420,000. And that's when we're going to break even. So the revenue has to be greater than $420,000 in order for the firm to be profitable with 800 billable hours. Now, what did the question ask? What amount has to be charged per billable hour in order to be profitable? So basically, the revenue is going to be the amount that we're charging per billable hour, let's call it X, times the number of billable hours, which is 800. Does that make sense? Basically, let me write this here in words just so you have something to refer to. Basically, in this case for this law firm, its revenue is equal to the fee per billable hour. Let's call it their fee per billable hour. The amount they're charging their clients times the number of billable hours. The fee per billable hour is what we're solving for. That's the X. And then the number of billable hours, we're given that. In this case, in April, it's expected to be 800. And so the revenue formula basically is 800X for April specifically. And so what we're figuring out is basically when is 800X greater than 420,000? And so when we divide both sides by the 800, basically X has to be greater than $525. So $525 is the minimum amount that has to be charged per billable hour in order for the firm to be profitable. So at $525, they're going to break even. So the amount has to be greater than $525 per hour in order to get a profit. And then any amount greater than $525, when you multiply by the number of billable hours, that revenue amount is going to be greater than $420,000, which is going to be greater than the cost, which is going to give you a positive profit. So maybe I explained that in a little bit, maybe I went a little bit overboard with these like inequality signs and all that, but hopefully you get where I'm coming from. Again, we're going to go into more detail discussing like break even and stuff like that in the next chapter. But yeah, if you get a question like this, this is basically how you solve it.